6.1 Pythagoras. Now in this unit, we're going to take a few steps back. Think back to grade 10, grade 11, maybe even grade 9. Pythagoras is a formula used to determine an unknown side of a right-angled triangle. Now there are two formulas in play here. Traditionally, we see a squared plus b squared equals c squared. But of course, this is solving for c squared. We really want to solve for c. So in my next formula, I've gone one step further and said, okay, c will be the square root of a squared plus b squared. Both are acceptable. We'll be using this one in most of our calculations. Now the first thing you need to do is ensure that you have a right-angled triangle. And of course, a right-angled triangle is one angle that measures 90 degrees. Usually you'll see a little box in the corner of that angle to indicate 90 degrees. Once you are sure you have that 90-degree triangle, you have to start by labeling your triangle. Now in our formula, we've got A's, we've got B's, and we have C's. 3 letters for 3 sides. The longest side, that's the one that's across from the 90 degrees, is called our hypotenuse. In our formula, we're going to call the hypotenuse C. The remaining 2 sides will be A and B. It really doesn't matter which we call A and which we call B. You want to identify which side you're going to solve for. Am I solving for the A, solving for the B, or solving for the C? You're going to substitute in the information you know into a formula and use order of operations to solve for that unknown. So let's look at 2 examples. Example number 1, we're going to solve for C. You might not see it, but that is our C. It's our side. Now the first thing we do is write down our formula. A squared plus b squared equals c squared. So in our first triangle, we need to label it A, B, and C. Now side C is across from our 90. It's the longest side. So we're solving for C, already pre-labeled for us. We now have to do A and B. And again, it doesn't matter. I'll call this A, and I will call this B. So I've labeled my triangle A, B, and C. I know I'm solving for C, which is isolated by itself on the equal sign. So I'm looking pretty good. Substitute into my formula. My A is 12. So I'm going to take 12 squared plus my B, which is 10 squared. And this is going to equal C squared. Now this squared is a unique term. A lot of people think it means times 2. 12 times 2, which is 24. That's wrong. We don't want to do that. What a squared means is you take the number and multiply it by itself 2 times. So this is really 12 times 12. A little bit of mental math, we know that's 144. So 12 squared is not 24, but 144. And then we have positive 10 squared. So 10 times 10 is 100. Positive 100 equals C squared. Order of operations tells me to combine these. 144 plus 100 is 244. So 244 equals C squared. Now, sometimes people think they're done, but they're actually not. We're not trying to solve for C squared, we're trying to solve for C by itself. So ask yourself, what's the opposite of squaring? And the answer is square root. So the square root is this symbol, the division sign with a little check mark on the top. So now we're going to take our calculator there. We're going to turn it on, clear it, and we are going to take the square root of 244. Each calculator is slightly different in how you are going to enter the information. For this calculator, I know my square root button is right here, which is the second function to this. So I'm going to hit second function, square root, and it pops up in my display. Well, what number do I want to square root? Well, it's 244. Close my brackets, equals 15.6204, and so on. Because my numbers given were down to the ones place value, I'm going to be one place value smaller. So I'm going to go 15.6. And of course, rounding, I look at 15.62 and my 2 rounds down. So it's 15.6. So my answer for C is 15.6. Now just a little check to see if you're doing things right. We did say that C will be the longest. Well, if I've calculated C to 15.6, it's longer than A, it's longer than B, I'm on the right track. Let's solve example 2. So example 2, write down our formula. A squared plus B squared equals C squared. Label my triangle. Longest side, across from my 90, is my hypotenuse, which is C. Now A is already labeled, that's what I'm looking for, so that means my other side must be B. Let's plug these numbers into my formula. I don't know what A is, so I leave A squared plus 8 squared equals 18 squared. So order of operations tells me to square these terms first. A squared plus 8 times 8, mental math, 64, equals 18 squared. 18 times 18, mental math, is 324. Now we get into a little bit of algebra. You got to think back to grade 9. You're trying to isolate A squared. Right now we have add 64. How do we get rid of add 64? We minus 64 to both sides. That equal sign is our balance beam. So if we're going to subtract 64 from the left, we subtract 64 from the right. Well, what do I get? I'm left with A squared equals 260. I'm going to move up here just to save some space. A squared equals 260. And we got to solve for A. We got to go back and do that square root. So I'll bring my calculator back on the screen, clear it because I don't want anything interfering with my calculation. I want the square root, so again, second function, square root of 260, close my bracket, equals 16.12. And again, one decimal place, so the 2 rounds down, 16.1. So my A equals 16.1. And again, I don't have any units on my diagrams, so I would have no units in my answers. So again, A was 16.1. Let's do that quick check again. I know my C has to be longest, 18. 18 is longer than A. 18 is longer than 16.1. So I'm on the right track.